Okay, the last lecture we have learned how to use integration to find area under a curve. Okay, so integration is more powerful than that. You can find the volume of revolution. Okay, can you all turn to your lecture notes? You can see page 38. Okay, all the diagrams, the notes are printed there for you, but please cooperate by not making a lot of noise. Okay, please don't. Okay, very simple idea. On the left hand side, the first picture, you see a region under a curve. Okay, any curve fx, you can have a region under the curve. Okay, R. Okay, now I want you to use your imagination. Imagine this region R rotated around the x-axis. Okay, what kind of shape do you get? Is it like a flower pot, like a vase, like a bowl like that? Okay, if your imagination is very good, this should be the volume that you will get, the solid that you will get. Okay, so now we can use integration to find the volume of this solid. Okay, you can not find any other volumes, only volumes of revolution. And in your syllabus, you'll be required to find volume of revolution around x-axis and y-axis. Okay, so now the next part is the explanation. Okay, how come you can use integration to find volume? Okay, it's something like the rectangles that we draw under the region, under a curve. Okay, the diagram, the third diagram you see there. Okay, you have divide the region under the curve into rectangles. Okay, just like what we did for area. Okay, so each one is a rectangle. Last time you know how to find area of rectangle, length times breadth. Okay, now I want you to imagine what happens if one of the rectangles, let's say the cave rectangle in the middle here, a typical rectangle, you rotate it around the x-axis. What kind of solid do you get? Are you able to imagine? It should be a cylinder. Anyone here cannot see a cylinder? Okay, anyone see other shapes? No, if you rotate a rectangle around the x-axis, go around, you see a cylinder. Okay, what's the width of this rectangle? We call it delta x. Delta x means a small increment in x. Okay, it doesn't mean delta times x, it means small increment in x, delta x. What is the radius of this cylinder? To find radius of cylinder, it's just the height of this rectangle. Remember how you find the height of this rectangle? You just substitute x into the function fx. Will give you the height. Okay, so just substitute xk into fx. You get the height of cylinder. That one will become the radius of this cylinder. Okay, so radius is fxk. Okay, which is the yk. Okay, that means the y value at k. Okay, then now to find volume of each disc. Volume of each disc is the volume of a cylinder. So how to find volume of cylinder? You can all remember what you learned in high school. Volume of cylinder is pi r square h. Correct? Anyone disagree? No, shouldn't disagree. Pi r square h. Okay, pi r square is a radius. R is a radius. So radius is yk. Pi y square k. What's the height of cylinder? Delta x. Okay, so that is for one cylinder. Okay, then if you want to find the total volume of all the n of these cylinders, okay, these cylinders are very flat cylinders, you have seen by now. So maybe you don't call it cylinders, you call it discs. Okay, they are flat discs. So you want to find total volume, just add up all these separate volumes. Okay, so how do you indicate that you add up everything together? The symbol is this sign. Okay, summation. Summation start from k equals to 1 up to n. Okay, start from left hand side, x1, x2, x3 up to xn. That's the last height, xn. Okay, so total will be the total volume. These that I drawn this diagram are still quite thick. Okay, now you have to imagine, like what I did the last time, imagine the rectangles become very, very thin. Imagine there are infinite number of rectangles. Infinite rectangles, then you get perfectly the region under the curve. Okay, then if you rotate it, you get perfectly the whole volume under the curve. Okay, so imagine, take the limit as n tends to infinity. What happens if n goes to infinity? Infinite number of rectangles. Okay, instead of summation, you find that you just do the integration. Okay, in fact, that's how the integration sign come about. Okay, so you wondering how come integration we use this funny symbol. Okay, you can imagine the summation. Okay, summation is like the letter S. Okay, initially when they started, they used the letter S. S is summation, but later they changed to this one is the Greek letter S. Okay, imagine what happens if you take the letter S and you do it. Okay, it becomes very long. Then you get the integration sign. Right or wrong? Okay, somebody get very excited. Okay. Become integration. Then all the other symbols are the same. Pi y square. Then the delta x. Now to use delta x, you use dx. Okay, remember when you do integration, always have a dx. So that's where the dx come from. Okay, so you do this, you get a volume. Okay, so on the next page, you see the formula. Okay, so this part of the chapter, this is the main formula. To find volume of revolution, the formula is integrate from a to b pi y squared dx. Okay, so this formula is not given, you have to memorize it. Okay, if you have a highlighter or what, go and highlight this formula. You must remember this by heart. Okay, some of you cannot visualize what I've been talking about just now, so now I try to demonstrate this volume of revolution for you. Okay, this one is roughly the function that's given on the page. Okay, refer to the diagram all printed there for you. Okay, if I just draw one rectangle under the curve, it looks like this, one rectangle. Okay, now then I imagine. Okay, now I imagine what happens if I rotate this rectangle around the x-axis. Okay, you should get this thing. Okay, let's try. There's a button here that says rotate. So I rotate. Okay, I think okay, I can show the rotation slowly. Okay, this is the rotation. Okay. Okay, rotate a rectangle. This is what you see. One disc. Okay, is a cylinder. Okay, can? Alright? Okay, then now I'll show you what if there are many rectangles. This one is roughly the region that you see on your lecture notes. There the region R. Okay, so now when you imagine many rectangles, now I rotate around x-axis. Okay, if you rotate, okay, can you imagine? Everyone over the screen please, this is what you should see. Okay, I press the rotate button. Okay, next slower you can see the rotation. Okay, you can see many rectangles. See or not? Okay, every rectangle rotate. Okay, so this is what you call a solid of revolution. Okay, so your job is to find the volume of this solid. Okay, that is for the x-axis. On the next page, you have exactly the same formula, but now for the y-axis. Okay, so now I'll show you at the same time, rotate around the y-axis. Find your lecture notes. Now I have a region along the y-axis. Okay, then now I'm going to rotate around the y-axis. Okay, let's show you one of these first, then after that many of these. Okay, again, find volume of one piece first. Okay, so take one rectangle, rotate around the y-axis. Okay, this is a rotate button. Okay, this is one piece. Okay, so how to find the volume of this piece? Pi r square h. Pi r square h. What is the radius of this disk here? Just now it was y. Now what's the radius of this disk? The radius is the x coordinate. So radius is the x coordinate of these points. Okay. And then what's the height of this disk? Is delta y. A small change in y. Okay, so this is what you get for one piece. Okay, so now we do the same thing. Imagine there are many rectangles and we rotate them around the y-axis. Okay, rotate around the y-axis. Okay, okay? Okay, seen enough of this already. Okay, so all this is just to help you to visualize. Okay, you must be able to see what the shape is like. Of course, these shapes here that I show here are the simple ones. Later in the example, then you see the more complicated shapes. Okay, so you must visualize the shapes, then you apply the formula to find the volume of revolution. Okay, so you need two formulas. Can you highlight the two formulas? Just now when you see rotate about the x-axis, the formula is pi y squared dx. Okay, dx means you integrate with respect to x. It's for rotation along the x-axis. If you rotate about y-axis, the formula now the x and y change place. Okay, integrates from where to where? From P to Q. Okay, because in this diagram, the y value changes from P to Q. Integrate from P to Q, x squared dy. Okay, dy that means with respect to y, it means you integrate along the y-axis. Okay, that means rotate about y-axis. Okay, so these are two formulas you need to remember, highlight them. Okay, that is all the theory behind it. Now we go to the actual examples. Example 7. Okay, a very simple curve. Y equals square root x. Okay, then now there are two parts in the question. Part 1, you ask, okay, what will happen if you rotate the region enclosed by this curve and the line x equals to 4, rotate about the x-axis. Okay, so first thing, you must draw the diagram. Okay, so the USBC square root graph, everyone should know. Okay, so there's some space, can you draw the diagram? Y equals square root x. Okay, just draw a simple xy axis. The graph y equals square root x. Okay, you must be able to see the shape first, then you can find the volume of revolution. So this is the curve C, simple shape. Okay. Then now the first part very simple. Integrate. They ask you to rotate around the x-axis. So you turn to the first formula that you highlighted earlier. You can get the answer straight away. The formula says integrate pi y squared dx. Okay, integrate from where to where? Okay, you want to find the whole region from 0 to x equals to 4. Okay, 1, 2, 3, 4. Okay, so just integrate from 0 to 4. Okay, there are two volumes, so maybe we call this volume x. Volume subscript x is equal to pi y squared dx. Okay, that's the formula that is given to you, pi y squared dx. Integrate from where to where? From 0 to 4. Okay, because I want to find the whole region from 0 up to 4. Pi y squared dx. Okay, but the formula is given like that, pi y squared dx, you cannot integrate straight away. Because y squared, how to integrate with respect to x? So everything must change in terms of x. So y squared, what is y squared in terms of x? The question says y is equal to square root x. So y squared must be x. Okay, so must change to x. Then when it's x, you can integrate. Okay, this is the simplest integral you can get. Integrate x, you get x squared over 2. Then substitute limits inside. Substitute 4, you get 8. Substitute 0, you get nothing. Okay, so the answer of that volume is 8 pi. Okay, so now I'll show you the applet again to help you visualize the next integration. Okay, all finished copying already? Okay, this is the diagram again. Y equals square root x from 0 to 4. Okay, notice that in this question they didn't say start from x equals 0. Okay, please pay attention. You can only know integrate from where to where by drawing the diagram. Okay, so you draw a diagram and the question says the region enclosed by the curve C, the x-axis, and the line x equals to 4. They only tell you x equals to 4, but they didn't tell you start from where. So from diagram you will see that you must start from 0 and stop at 4. Okay, so this one you're working out yourself. Again, let's do the rotation. So this region rotates about x-axis. Okay, this one simple shapes, so that's why you can see quite easily. Okay, let's press the rotate button to rotate about x-axis. Okay, you want to slow down? Okay, slow down, so this is the rotation. Okay, now let's do the other one. The region when you rotate about the y-axis. Okay, this one a bit harder to visualize, so we'll try. Top there are buttons that say x-axis, y-axis. Okay, so that is for you to change, to select whether x and y-axis. In your syllabus, only these two axes of revolution, either x or y-axis. Okay, this is the shape again, y equals square root x. Now the region is different. If you look at the question, they say the region enclosed by the curve C, the y-axis, and the line y equals to 2. Okay, so in all this you must choose the limits correctly, then you draw the region out for you. Okay, then now this is the region, now we rotate about the y-axis. Okay, so how's your imagination? Can you imagine the shape when you rotate the y-axis? What does it look like? Is it like a ice cream cone? Yes. A bowl, a cap, party hat.
Okay, stop there, please.
Okay, so that's the shape. Okay. Correct? This is the shape, okay? Yeah, okay. Okay, so now you can imagine the shape. So now apply the formula to find the volume of revolution. Okay, so sometimes you cannot see, you have to zoom in a bit so you can stretch. And I programmed it so that if you zoom in a few times, the word HCI will appear at the bottom corner. Yeah, if you zoom in a few times, all my applets, you see the HCI appear. Okay? This is my copyright. So make sure. Just to make sure other people don't go and steal my applets.
哇，要 steal 你的 applet 直接是考源代码。
Okay, this is the answer for the second part. Okay, first part here, I'm going to find out x squared. Okay, I find x squared in terms of y because I know later I'm going to integrate pi x squared dy. Okay, but if you don't know, you just write it down first. Okay, when region T rotated about the y-axis, the volume, okay, volume let's call it Vy. Okay, so you look at the second formula that you have highlighted. The formula says pi x squared dy. Okay, integrate from where to where? Just now you see the region is from 0 to 2. Okay, again, x squared cannot integrate with respect to y. Okay, that's why x you must express in terms of y first, then you can start to integrate. So the question only say y equals square root x, which means x is y squared. So x squared is how much? Y to the power of 4. Okay, so x squared is y to the power of 4. You write it down, then now this is something you can integrate again. Y to the power 4, the answer is y to the power n plus 1 over n plus 1. Okay, then substitute 2 inside, you get 32 over 5 pi. Okay, so that's the answer. Okay, notice that in this question, they ask for the exact value in the question. So you must do the integration and find exact answer. If the question didn't say find exact value, you can give answer in decimal, and you don't even need to do the integration. What's the reason? If the question didn't say find exact value, you can give a decimal answer. And if you want to find decimal answer, you don't even need to go through this integration. Use your graphing calculator, very good. Okay, your GC can do this integration for you in one step very easily to get the numerical answer. Okay, but simple cases like that, they definitely want you to find exact values. Okay, now we have done all the simple shapes. Okay, so I think most of you will say no big deal, I can handle that. Okay, so that is for one curve. Okay, the next section is what happens if you have two curves, fx and gx, and then you want to find some volume of revolution that's generated by those two curves. Okay, so the theory is down there. Okay, now let's have two curves, fx and gx. Okay, just for simplicity, the fx is greater than gx. So f is on top, g is below. Okay, but both are positive. Both are above the x-axis. Okay, then you want to define a region R bounded by these two curves between x equals to a up to x equals to b. Okay, so you have a region. You can refer to a diagram in your notes there on page 40, quite nicely drawn for you. Okay, then now you rotate the region about. Okay, so this is the region between fx, gx, between a and b along the x-axis. Okay, the region in the middle. Then if you rotate the region around the x-axis, okay, you'll get this shape. Okay, later then I'll show you, demonstrate for you. Okay, but now the shape looks like this. Okay, now it's not a simple flower pots or bowl or party hats. Okay, you get some solid that has something hollow in the middle. There's a gap in the middle because the region down there is not counted. Okay, so there's a region. So if you take this rectangle and rotate around x-axis, now you don't get just a cylinder or like this. Okay, you get a cylinder. Okay, maybe a donut. Some of you imagination very good. You can see donut makes me feel very hungry. Pandan cake. Okay, you all have very good imagination. So it's this with a hole in the middle.
No link.
Okay, some of you can see your saliva dripping already. Actually not that food. Okay, so how to find the volume of this donut or pandan cake or pineapple? To find the volume, you must take the. You must subtract the volume of the gap in the middle. Okay, the missing part in the middle. Okay, so you must take the big volume minus the small volume. Big one minus the small one. Okay, the two integrals are given there in the formula. What's the big volume? I y squared dx. Okay, but now we don't use y because y have two meanings in this question. Okay, can you all pay attention at the back, please? Okay, how to find the big volume? The volume of this big shape here. Big, the whole solid here. Pi y squared dx. Okay, but for the big solid y, you use fx. Because the big curve up there, y is equal to fx. Okay, so to find the big volume, pi fx squared dx. Okay, is actually the same formula, pi y squared dx, but the y you replace by fx. Okay, that's for the big solid. Okay, how about the missing part in the middle? The whole part they don't want. The volume of that one is also pi y squared dx. But for the bottom parts, the y is equal to gx. So that's why the formula is like this. Okay, it looks quite scary the first time you look at it, but it's the same formula. The big one minus the small one. Then you get the resultant volume. Of course, when we do integration, there's no need to find two separate integrals, get the answer and subtract. Okay, you can shorten your working by combine the two integration and do it together. Okay, so instead of first integral minus second integral, you can put them together, integrate one time only. Fx squared minus gx squared. Okay, sometimes this fx squared and gx squared you can cancel and simplify the expression. Okay, so that is the formula. Okay, let's look at the question first, example 8. Okay, you have a diagram given to you, the region R. What's the curve? Half x squared plus 1 is the curve. Okay, you want to find the region enclosed by this curve, the y-axis, and the line y equals to 3. Okay, so that is defined for you. If the diagram is not given, you have to draw yourself and identify the region. Okay, then you know what the shape is like. Then now you have to rotate this. Okay, now it's not just rotate about y-axis. Don't read the question wrongly. If I rotate about the y-axis, it's very simple. I can get the answer in one step. Okay, pi x squared dy. I can get the answer. The difficult part in this question is now you have to rotate about the x-axis. Okay, so it's not so simple. Okay, so let's now use the applet to try to visualize what the shape is like. Okay. Otherwise, can you all imagine what the shape is like? This region R rotate about the x-axis. Can you see what the shape is like? Is it still a donut, a pineapple, pandan cake? Not quite, huh? Okay, this is the region. Okay, about. Okay, I've drawn the shape out. It's the blue color region that we want. Okay, now this blue color region, this is the curve y equals half x plus 1, half x squared plus 1. Now this is the blue color region, this is the region R given the question. The red color one, you ignore it first. Then now the blue color part, I rotate about the x-axis. Okay, I want to find that volume. Okay, how to find the volume? Okay, let's press the rotate button and rotate. You can see whether your imagination is correct. Okay, whether you get the correct shape. Let's try. Okay, the rotation will result in this shape. Okay, the blue region I rotate. If I just take the straight line y equals 3 and rotate, I'll get a cylinder. The part that's below the curve, if I rotate, I'll get this funny shape here. Okay, like a hat that's sideways or something, a vase or something. Okay, so now how do I find the volume of revolution of the region R? Okay, now to find it, can you see that I need to minus what minus what? I need to find the volume of the cylinder first minus the volume of these red color parts. Can you all see that? Then that will give me the answer that I want. So the volume of the cylinder minus the volume of the red color parts. Okay, because at first the region is like that, the blue color parts. Okay. Then if I rotate, I will get a cylinder. Okay, you must be able to visualize it's a cylinder when you rotate. Okay, because if you can see it's a cylinder, you can find the volume without doing integration. You all know the formula for volume of cylinder. Okay, it's only the red color parts that I need to integrate. Okay, so when you rotate, it's a cylinder minus the red color parts. Okay, so this is the part where your imagination or your visualization need to be very good. Okay, otherwise you cannot see the shape. Then you may do the integration wrongly. Okay, so now let's see the actual working. Okay, the first part is to find the intersection of the two curves. Okay, because now I'm rotating along the x-axis, I need to find the x-coordinates. So I'll just find intersection between the curve and the line y equals to 3. Okay, just equate to 3. Equals half x squared plus 1, then solve, and it gets x equals plus minus 2. Okay, of course from the diagram you can see x is positive. So you reject the negative answer. So half x squared equals to 2, x squared equals to 4, so x equals to 2, positive. Okay, and then now we just apply the formula that is given to you. Okay, if you can see there's a cylinder, you can even simplify this working. You only do one integration. Okay, but now let's apply the formula given to you to be consistent. Okay, you must know that it is the big volume minus the small volume. So what's the big volume? Remember the blue color parts? That's the curve y equals to 3. So y equals to pi y squared dx minus the smaller one, the red color parts. Okay, so the top parts, pi y squared dx, y is equal to 3. The red color parts, pi y squared dx, y is now the curve, half x squared plus 1. Okay, notice that down here we don't go and integrate separately and minus. That one is more tedious. You simplify the working by combining the two integrals into one. So expand all the, open up the brackets, subtract together. So 9 minus quarter x to the power 4. Okay, just be careful the minus sign. Minus 2 times half x squared, which is x squared, and minus 1. Okay, simplify first. Okay, 9 minus 1 is 8. Integrate, you get 8x. Integrate x to the power 4, you get x to the power 5 over 5. And integrate x squared, you get x cubed over 3. Okay, then you substitute the values. Okay, substitute from 0 to 2. Okay, remember now you are integrating along the x-axis. We are rotating along x-axis. So don't get confused by diagram. Don't go and integrate from 1 to 3. 1 to 3 is along the y-axis. That got nothing to do with your volume of revolution. You are revolving from x equals to 0 to x equals to 2. Okay, integrate the any other questions that you want to ask? Okay, if no questions, this is a very good place to stop. Continue next week, Tuesday.
Very good place to stop.